Audio Jungle. Audio Jungle.
Hello everyone, this is my final output in data mining, Maternal Health Risk Dataset. Maternal health refers to the health of women during pregnancy, childbirth, and the postnatal period. This dataset talks about the risk of woman pregnancy, health problem, or complications of woman pregnancy. In the dataset includes of BS that are represented to the public locus level in terms of molar concentration, systolic BP which measures the pressure of arteries, heartbeat, or the upper value of blood pressure. Body temperature represents the average of the normal body temperature. Heart rate, it is a normal heart rate in beats per minute. Age, which represents the age of the patient's woman during pregnancy. And lastly, the risk level, which is one of the important things pertains to the woman's pregnancy because it represents to predict or identify the risk intensity level during pregnancy, whether the patient is in high risk, mid risk, or lower risk. So, all of these are the responsible and significant risk factors for maternal mortality that is one of the main concern of SDG or UN. This is the dataset of maternal health risk. The data has been collected from different hospitals, community clinics, maternal health cares from the rural areas of Bangladesh through the IoT or Internet of Things based risk monitoring system. In this dataset, we have a numbers of instances which is 1014 and the number of attributes is 7. So as you can see, all data are not organized as well as not normalized. Here is the maternal health risk data normalization. So in some shortcut, I applied normalization from WECA to my dataset in order to normalize it. For first, go to WECA Explorer, then open file. After that, I select maternal health risk dataset. Then I already check all these attributes from 1 to 7. Then after that, apply. Then you can see the statistic and value, which is the result of normalization. So in this, the minimum is 0, the maximum is 1 here, and the mean is 0.331 and SDP dev is 0.225. As you can see, the normalization is done. However, its attributes are not organized by its column. So messy, right? Therefore, we're gonna use sorting in the set to organize or to arrange it into meaningful order so that we can analyze to more effectively from high to lower risk level. This is how to sort data set. First, go to Excel here in the left side. Then open the data set and click the data to arrange all the data. It can be smallest to largest here or largest to smallest. In that way, I used largest to smallest. In Excel, you can sort your table by one or more columns or by custom sort. This is the result of finished dataset of maternal health risk ascending to descending order. The next is we gonna do is to remove data outliers. We can analyze it effectively and determine the fields to remove. So now this is the data highlighted here that is that we need to fix and change according to the data. So we can analyze the wrong fields. By summarizing the process of data mining, we remove all data we identified with the help of this method, because this kind of data, it causes the result to become statistically significant. In short, all outliers are problematic and should be removed. Errors, data entry, or processor error. So as you can see, we have a high risk, mid risk, and lower risk, which is done by pre-processing. Here we can analyze the high risk level from 0.9. So if it is more than 0.9, it is a high risk. Then if it is less than 0.9, we can analyze it as mid risk, and below 0.4, we can analyze it as a low risk. So what is clustering? Clustering in WECA supports several clustering algorithms such as EM, filtered clusterer, hierarchical clusterer, simple, k-means, and so forth. When clustering, a group of different data objects is classified as similar objects. It means that the data sets are divided into different groups in the cluster analysis, so which is based on the similarity of data. The k-means clustering algorithm is used in the dataset to find groups which have not been to confirm business assumptions about what types of groups exist, or to identify unknown groups in complex datasets. The next one is classification. There are different kinds of classifiers in WECA. First, bias, classifiers, functions, lazy, meta, miss, rules, and trees. These classifications in data mining is used to categorize the data into a class or category. It can be performed on both structures or unstructured database. There's three types of classifications such as binary, multi-class, and multi-label classification. So additionally, a classifier identifies an instances class based on training set of data. You can visualize the trees in WECA to see what attributes they use and what tests they make on them. Like all classifiers in J48 has a configuration panel in which you can set parameters that affects how it operates. So this clustering and classification is what I use in my dataset. So now, tends to the result of clustering. So here in the left side, number of iteration is 7. Within the cluster, sum of squared errors. So clustering identified the squared errors is 17.66, and we have clusters, 6 clusters, which is cluster 0, cluster 1, cluster 2, cluster 3, cluster 4, and cluster 5. So the time taken to build node full training data is 0.01 seconds, and the cluster instances are cluster 0 is we have 127 and 13%, cluster 170 37%, cluster 2 318 31%, cluster 3 230 23%, cluster 4 140 14%, cluster 5 129 13%. So as you can see, the final cluster centroids, the data set are divided into different groups. So we have, on the left side, we have age, systolic BP, the elastic BP, bias, the temperature, heart rate, and the clusters from 1, 2, 3, 4, and 5. So as you can see here, the result of clustering. This is the clustering graphical result of maternal health risk dataset. So in this, as you can see, if it is color blue, this is cluster 0. If it is color red, this is cluster 1. If it is color green, here it is cluster 2. And if it is color blue, cluster 3. And if it's color peach, it is cluster 4, and purple is cluster 5. So we can analyze it more effectively by using this graphical result of clustering in Weka. The next one that I gonna use is the classification, this is the result of classification result. So the classifier output is stratified cross, validation, summary. Correctly classified instances is 1014. Then incorrect classified instances is 0. Kappa statistic 1. Main absolute error 0. Root mean squared error 0. Relative absolute error 0. Root relative squared error 0. Total number of instances are 1040. Now let's move on to the confusion matrix. This is the confusion matrix of the dataset. The confusion matrix assign letter A, B, and C to the values and provides spec class values classified as for each column. So high risk correctly classified 87 instances, and there is no incorrect errors from B to C. Then to the mid risk 506 instances correctly classified, and there is no incorrect errors. The next one is low risk, which is 421 correctly classified, and there is no errors, or there is no incorrect errors. So this is a perfectly result in classification. So let's move on to the decision tree graphical result. Diagnostic BP, or if it is less than or equal 0.411765, it is classified as low risk, or 280. When it is greater than 0.411765, it is what we call, it is either mid risk or high risk. So in the diastolic BP, if it is less than or equal 0.901961, it is classified as mid risk. And if it is greater than 0.901961, it is classified as high risk. So, summary and recommendation. Knowing the types of data you are dealing with enables you to choose the correct method of analysis. In the data processing, it helps to improve accuracy and reliability. Also, it removes those missing or inconsistent data values resulting from human or computer error. In short, it makes data consistent. Classification and clustering is what I use in my dataset. So these two techniques have some similarities. The difference is that the classifications uses predefined classes in which objects are assigned, while clustering identifies similarities between objects, group them based on these common characteristics, and compares them to the other groups of objects are extracts. So these groups are called clusters. So to analyze the graphic result in clusterings, from clusters 0 to 6, they are in the group positions between central of each clusters measures how often a nodes or edge lies on the shortest part between each pair of nodes based on the graphic results. In short, the result of clustering is one that achieve the best quality of during the process. In classification analyzation, the result generates an output that classifies the input into some category. In confusion matrix in high risk, there is 87 instances correctly classified, and there is no incorrect errors from A and B class. Secondly, 506 instances are correctly identified, same as in high risk, there is no incorrect error. Finally, in low risk, there is a 121 instances correctly classified and no incorrect error. To sum up all the instances, we have 1014 numbers of instances. In the elastic BP, if it is less than or equal to 0.411 something, it's classified or predicted as low risk, and when it is greater than 0.4, it is classified whether it is a mid-risk or high risk. Therefore, if the data is less than or equal to 0.901, it is classified as mid-risk. However, if it is greater than 0.0901, it is classified as high risk. The result of all methods in data mining helps to categorize the given topic data set into a class or category. Basically, when the use of those types of method in data mining, it's a greatly tools to organize data in simple way, and so on. Therefore, I determine the result of maternal health risk dataset and simply classify the data in easiest way, which they are belong to the class risk level, whether the data are in low risk, mid risk, or high risk. So that this main concern of SDG of UL with the gathered dataset will be solved by the data mining techniques, which is essential tool in the environment of health for the purpose of prediction, clustering, and classification. And that's it. Thank you for watching.